Okay. Anyway, I start.
Yeah, sure.
Yes, thank you. First of all, let me introduce my colleague, Twin. Unfortunately, I can't speak Chinese, but he can speak both Chinese and English. He will support me in particular Q&A time. This session is in English, but any comments in Chinese are also okay, since he will translate. Okay, let's start my talk. Okay. Okay. First, please let me briefly introduce myself. My name is Nozomi Kurihara, and I am a software engineer at Yahoo Japan. I have been working on an internal messaging platform using Apache Pulsar in Yahoo Japan for about 4 years. And also, I am a committer of Apache Pulsar. Anyway, let's see today's agenda. Today we have 5 sections. First, I will briefly introduce you to Yahoo Japan. Next, I will explain our Pulsar adoption story and use cases. Then I will talk about 4 years operational experiences and finally explain future plans. Okay, let's start the first section about Yahoo Japan. First, I will explain the situation in Yahoo Japan. Yahoo Japan is one of the biggest portal sites in Japan. This is the top page of Yahoo Japan. Okay, I'll show the 3 number which represents how big Yahoo Japan is. Here we've got these 3 numbers. What are they? Do you have any idea? Okay, don't worry, I tell you. The first one is the number of services in Yahoo Japan. Yahoo Japan has a lot of services like auction, shopping, news, weather, game, finance, mail, and so on. And note that the number keeps growing. And the second one is the number of servers. Note that they are all real, not virtual. In order to handle 100 plus over services, more than 150,000 real servers are running 24 hours a day. Sorry. Okay, the third one is the number of end users. There are about 80 million end users. It implies that there are so many customers visiting our site. As you can see, Yahoo Japan is a huge site. Next, I will explain how Pulsar is provided in Yahoo Japan. Yahoo Japan has used Pulsar for about 4 years. We use Pulsar as a centralized messaging platform. In other words, there is a single Pulsar and a lot of services use it as a tenant. So there is a Pulsar team. So there is a Pulsar team, including me, and they are maintaining Pulsar. There are many service teams such as auction, shopping, and mail, and they are using the same single Pulsar as tenants. Next, I will explain about our users. In this talk, users mean service developers in Yahoo Japan. Today, we have more than 260 tenants and 7,600 topics, and a lot of subscriptions, producers, and consumers, as these numbers shows. Typical use case are notification, job queuing, and log pipeline. let me briefly introduce Pulsar promotion in Japan. We have held meetup events in Tokyo 4 times so far. These meetups include hands-on and use case talks. We have talked in other communities such as JJAG, Japan Java User Group, which is the largest Java community in Japan, and Kafka Meetup, and in which we talked about comparison of Kafka with Pulsar. And currently, we write some blog posts in Yahoo Japan's tech blogs, which introduces Pulsar's architecture and client libraries. Let me move on to the next section. I will explain adoption, in other words, why Pulsar was chosen in Yahoo Japan. And this figure illustrates the history of Pulsar and Yahoo Japan. Originally, Pulsar was born on Yahoo Inc., now Verizon Media, and Yahoo Japan made Pulsar in 2016. We joined its open sourcing project, and finally, September in 2016, Pulsar was open sourced. Also, we started using Pulsar in production in 2016. In 2017, Pulsar was moved to Apache, while Yahoo Japan started to use WebSocket and C++ client. In 2018, Pulsar was promoted to Apache top-level project. At the same time, Pulsar's version is bumped up to 2.0, and YJ started to use it. And also, we have scaled out our cluster in 2018. In 2019, we developed and released Pulsar Node.js client. And in 2020, we are now planning the second scale up since more and more users start to use our internal Pulsar. Why Pulsar was chosen? The answer is because Pulsar has a lot of notable features such as high performance, durable, and so on. Also, Pulsar has no specific weak points. Consequently, Pulsar covers various scenarios. And that is very important in the situation where various services are using it, like Yahoo Japan. That's why Yahoo Japan chose Pulsar. In particular, these 3 features are specifically important for Yahoo Japan. I will give you more detailed explanation about these 3 in the next few slides. First, multi-tenancy. Multi-tenancy means multiple services can share a single Pulsar system. Before introducing Pulsar, each service has own messaging queuing systems. In other words, they have to prepare servers and maintain the system. That is obviously extra cost for service engineers. On the other hand, after introducing Pulsar, each service and application can just use Pulsar as a tenant. So they do not need to maintain their own messaging system anymore and can concentrate on their service logic. As a result, a lot of services can work on only one Pulsar, and then we can reduce total costs. And that is quite important, particularly in a lot of multi-service situations like our company. And authentication and authorization is important in multi-tenant situations. There are a lot of tenants, so if one tenant accidentally sent or received messages from topics which belongs to others, that can be a serious problem. And of course, protecting data from attackers is important too. Pulsar has authentication and authorization mechanisms. You can use various plugins such as TLS Mutual Authentication, JOT, Kerberos, and so on. Yahoo Japan uses Ascent's open source security system originally born in Yahoo. Moreover, Pulsar's authentication and authorization are pluggable. So you can easily add another plugins by implementing some classes. Next, I will explain the scalability of Apache Pulsar. Scalability is quite important to deal with increasing end users or traffics. Fortunately, Apache Pulsar is really scalable system. To increase the capacity, all you have to do is just add servers. Moreover, since the serving layer and the storage layer is separated, you can flexibly add brokers or bookies according to the situation. Thanks to this flexibility, you can save on costs and leverage hardware's resources more efficiently. In our case, we have experienced scale out at 2017. We increased the number of brokers from 3 to 15 and bookies from also 3 to 10. Indeed, at that time, all we have to do was adding servers and which smoothly expands the system without stopping it. Next, geo-replication. The background here is multiple data centers. Our requirement is some users want to replicate messages to remote in order to consume each cluster or backup for disaster recovery, etc. Pulsar has awesome geo-replication feature. We can easily enable it for each topic by just configuring replication settings for namespaces. In our case, most of users use this feature. Okay, next section, I will explain our use cases. The first example is notification of contents update. The situation is that various content files for example, weather, map, and news data are pushed from partner companies to Yahoo Japan's file server. Services want to know the update of these content files. Such services subscribe to a specific Pulsar topic, and when contents are updated, notification message is sent to the topic. Then services receive a notification, and then they fetch the actual contents from file server. Like this, you can use Apache Pulsar as notification transferring system. Okay, the second use case is job queuing in Yahoo Mail. What we want to do is indexing mails. The problem is that it can be heavy sometimes, so we want to do it asynchronously. First, if a mail backend server receives a job request, it registers the job to Pulsar topic. Another server takes the job from the topic and processes it. And if the job fails, it will be re-registered to the topic. Like this, you can use Apache Pulsar as asynchronous job queuing. The third example is log pipeline. First, let me introduce our situation. Currently, in Yahoo Japan, almost all applications are running on PaaS, platform as a service, like Pivotal Cloud Foundry, or CaaS, container as a service, like Kubernetes. Any service developers deploy their apps on PaaS workers. Then it's natural requirement to monitor their apps. In our company, we have some monitoring platforms such as Splunk or Yamas. where Splunk is a log searching platform and Yamas is a monitoring platform like Grafana. Later, I'll introduce the detail of Yamas. What we want to do is to send application logs and metrics to monitoring platforms so that service developers can monitor their apps. Okay, this is a long pipeline architecture using Pulsar. Thanks to this well-decoupled architecture, we can easily scale out and also traffic spikes are mitigated by Pulsar layer. Okay, let me move on to the next section. Next, I will explain our operational experiences. First, I explain what my team do. For internal purpose, our mission is to provide fast and reliable messaging platform for service developers. We maintain Pulsar clusters, includes some components such as brokers, bookies, zookeepers, and Web UI2 for managing topics. Also, we maintain some internal documents and supports users' questions and troubles. And for open source community, we sometimes send pull requests, typically bug fix, and also do promotion in Japan. This is a simple illustration of system architecture in Yahoo Japan. We have two clusters, and one is located on west and another is east. Sorry, concrete name of these clusters are confidential, so let me call them just west and east in this talk. In each cluster, we have brokers, bookies, zookeepers, and WebSocket proxy servers. Note that WebSocket proxy can be enabled on brokers. However, in order to avoid WebSocket proxy process affects broker process, so we separate them physically. Also, we enable geo-replication, so messages are replicated across these clusters. Here is the server spec. For broker, bookies and zookeeper servers, we are using real servers in order to deal with large traffics. Note that bookies has two types of disk, SSD for journal and HDD for ledgers. And for WebSocket servers, we use virtual servers for scalability. And these graphs show the traffic for one cluster. We have seen 100 kilo message per second and 100 megabytes per second produces. And also 600 kilo messages per second and 600 megabytes per second consumes at peak time. And these numbers are growing. We provide Web UI2 for managing topics. Through the UI, users can create tenant namespace and configure their settings by themselves. And users can see topic stats, for example, average message size, throughput, and subscriptions. So Pulsar team do not necessarily know detailed settings of all tenants anymore. The management of each tenant is delegated to each user. And this is quite important, particularly in the case where there are many tenants. Next, I will explain monitoring topics. Here we are using Yamas. Yamas is a SaaS-type metrics monitoring and alerting platform. It was originally developed in Yahoo and recently Yahoo Japan starts to use. Note that it will be open sourced for now, not yet, but soon. So if you are interested, let's try. In Yahoo Japan, we are using Yamas as a monitoring tool on Pulsar topics. To do so, broker stats are taken from Pulsar's admin API, and also outputs are sent to Yamas. And finally, any service developer can watch their Pulsar topic stats and also create any alerting rule based on them on Yamas dashboard, like this. For example, they are watching their backlog size or producing and consuming rate, etc. Okay. Next, I explain troubles we experienced. Generally speaking, there is no completely bug-free software. Pulsar is really awesome product. However, we have experienced some problems so far. I will introduce some of them. However, note that the purpose here is not negative campaign, but to share our experiences and how we solve that. I hope that will help you your future Pulsar operations. Okay. The first one is infinitely increasing clients. The problem is some users increases clients infinitely. For example, generating a producer for each time sending a message. That will cause exhaustion of file descriptors or broker servers. To solve this problem, we added some broker settings to limit the number of producers and consumers. These settings will prevent clients from increasing infinitely. And the lesson we learned is here. First of all, users can make mistakes. So considering that and preparing in advance server-side responsibility in multi-tenant scenario. And thus, restricting quotas and client capability is quite important to guard whole system. Okay, next. The second problem is backlog. Users often encounter producer blocking caused by backlog exceeded on topic. Typical cause is inactive subscriptions. In other words, subscriptions without any consumers. For example, in developing phase, users create some test subscriptions and finally often forget to delete them. That causes backlog later, since messages not acknowledged by at least one subscription are kept in backlog. Another case is replication backlog. If geo-replication is enabled, messages will be replicated to remote clusters. However, if there are slow or inactive subscriptions in the remote cluster, then backlog can be full in the remote cluster. Then replication gets failure since remote backlog is full. And that increases replication backlog in the source cluster. And finally, replication backlog becomes full too, and that blocks producers in the source cluster. And there is no general solution since it depends on client-side situations. You can choose following options. First one is to use consumer backlog eviction. By setting this policy to namespaces, old messages will be replaced with new messages when backlog is full. If discarding is acceptable, this setting is helpful. Second one is message TTL. By setting it, messages will be expired. That mitigates the possibility to become backlog full. However, if a large number of messages are published in a short time, the problem still can occur. The third one is subscription expiration time minutes. By setting it, subscriptions without consumer will be expired. The lesson here is it's important to make users understand backlog and app concepts well. And we need to choose the best option according to their service requirements. A third problem was occurred in Bookie SSD. Currently, we see more and more users start to use our internal Pulsar. Naturally, as users increase, SSD writes increase. That causes heavy workloads on SSDs and exhausts them. Indeed, we have seen frequent failure of SSD. To solve this, first we tweaked Yamas group weight MSEC setting. It controls the trade-off between write frequency and the least latency to group multiple writes. By increasing this value, number of writes decreased at the sacrifice of the least latency. However, unfortunately, our SSDs had been already quite exhausted. So finally, we decided to replace them newer, higher spec disks. The lesson here is journal writes can be the first bottleneck, so pay attention to Bookie's disks, particularly when traffic increase. And the fourth problem is deadlock. Unfortunately, we have experienced deadlock several times. Normally, if a broker goes down, then the owner of topics will change soon and producers and consumers back to normal. However, if a broker gets stuck by deadlock, the owner change will not happen. And as a result, producers and consumers keep failing until the broker is restarted. There is no general solution since the cause of deadlock vary. To make matters worse, producing this kind of problem is often difficult. Only one advice is to investigate the output of JStack command. It often includes the cause information, but if we restart the broker, the output comes back normal. So we finally decided to correct it periodically. And the lesson we learned here is deadlock is inevitable, unfortunately. However, when we encountered this kind of problems, we report it as the issue on GitHub. And then a lot of community members helped us. For example, giving us some insights or directly fixing the issue. So we are very appreciated our Pulsar community. And I think such user feedback and community support cycle is the most important advantage of open source projects. So my final conclusion here is that if you encounter any problem, do not hesitate to open an issue on GitHub. Then hopefully someone may help you. So far, I explained our Pulsar use cases and experiences. Finally, I explain our future plans and conclusion. Here is our future plans. For internal use, we are now using version 2.4.2, but disabling some features such as eShare subscription and replicated subscriptions. These features are often asked by users, so we are planning to enable it as soon as possible. Also, we are planning to use next version up. We will use 2.6 or 2.7 on January or later. For open source, we will continue to improve Node.js client in the near future. We will release version 1.3, which includes some feature updates. And these are our interested or expecting features. They are recently introduced or discussed in the previous Pulsar Summit on June or GitHub. In our case, we have much larger number of consumers than producers. So we expect read-only brokers will improve scalability and performance more. We are often asked how to filter messages by internal users. So we expect that broker-side message filtering will help them when consumers are only interested in some parts of messages. Okay, this is the last slide. In my conclusion, Yahoo Japan uses Pulsar as a centralized platform for various services. Pulsar plays an important role in various situations, such as notification, job queuing, and log pipeline. Overall, Pulsar's operationality, such as multi-tenancy, stateless broker, and scalability, really helps our 4 years operation, even though some problems occurred. I hope and we want more improvements and evolution on Pulsar. So my last words in this talk is enjoy your Pulsar life. Okay, my talk is all finished. Thank you for your time and interest.
Thank you, Nozomi. Thank you very much for sharing the practice, the use case of Apache Pulsar on production. From your talk, we know how to operate a Pulsar for large-scale data stream. You know that our talks are broadcast on both Hopin and other platforms in Asia, and there are some questions from our Asia platform. Would you mind to answer those questions at the moment? Maybe I can just select some of them. One said that from your talk, we noticed that the number of web page views and your business expand rapidly. Could you share the most challenging things you might in business expansion when using Pulsar? The most challenging things you might in business expansion when use Pulsar? Could you hear me?
Sorry, the most challenging.
The most challenging.
Yes, yes.
Yeah, the most challenging things.
Your question is sorry. I couldn't catch that.
Okay. The most challenging thing you might in business expansion when using
changing things.
Yes, yes, yeah. The challenging things you might. Maybe we can skip to another question. This may be easier. Another one asks, how many people? Yeah, how many people know Pulsar and use Pulsar in Japan? Do you know the numbers?
Sorry.
Could you hear me now? Hi, Nozomi.
Yes. Actually, yes. Actually, no. Hi.
Hi.
Yes.
Yeah. Another one asks, how many people know Pulsar and use Pulsar in Japan? Do you know the numbers?
Number of users is actually one. Yahoo Japan only for now, but we are promoting now.
Oh, that's great.
Does that answer your question? Sorry.
Never mind. Or maybe I can show you those questions in the helping platform and you can answer them. Maybe we can also have other channels and you can answer those questions for them. Is that okay? Okay, so if so, we thank you very much for sharing. And okay, and now we can also have a look at how Apache Pulsar.
Okay. Yes.
Yeah, we can just skip to the next stage. Okay.
Thank you.
Thank you.